Good afternoon, I'm John.
I'm David.
And we're here to talk to you today about the handheld Penetrometer. Ba-ba-da-ba-ba-ba-ba! No, today we're here to talk to you today about hydronic heating type 2, and we're actually going to do another piece to this video on thermal shock. And that's what I wanted to talk to you today about, David. And so we are going to talk about hydronic heating today. This is part 2 from our part 1, to be concluded. And then in the next week and a half, we're actually going to do a slab with that hydronic method to show folks how to do it.
That'll be interesting.
Now, where I was going before somebody so rudely interrupted me was David is one of my favorite engineers. He came up with the phrase, more data equals better science. I don't care what you say. You came up with the phrase. He also wrote the books Fun with Trusses, Concrete Strength 1, 2, 3.
Yeah.
He is the stress strain guy.
I'm a stress strain guy.
Stress strain guy. He even taught it at university.
I did. Taught at the University of Colorado, Denver.
So, what we're going to talk about today is hydronic temperature control. I don't want to say heating. So here in Colorado, we're in that funky time of the year when it doesn't know if it's spring or if it's winter. Like Patchouli and I were walking up behind the house today, and all the trees were starting to bud.
Yeah, I know.
And we still have some major storms in front of us.
No doubt.
So I love that. Like March, April, we can actually still get snow. March, we definitely get snow. April,
March is the heaviest snow month.
Oh, when I was at the prep school at the Air Force Academy, we graduated, we had a foot of snow on the ground in places.
Yeah.
It was just in May. In May. Anyway, so that being said, construction still has to go on. And the reason why we brought up this hydronic concept, temperature controlling, is that if the job still must go on, it's either you're going to make good concrete or bad concrete. Or it's not that you're going to make bad concrete, but that negative 15 degree Fahrenheit snap, which we were supposed to have 30s, which in December, that's normal. All of a sudden, we got a snowstorm, a blizzard. Dude, it was a Wednesday night. I looked out the window, I was like, holy crap, baby. There's a blizzard outside, and it got negative 15. If you had just placed the slab that day and had just set it up for a 20 degree evening or a 10 degree evening, whatever blanket you were using,
Not enough.
not enough. And that turns your good crete into...
Bad crete. Crap crete.
That's what Whitney calls it, crap crete. You know, for as good as a person she is, she cannot get past that. And there are methods out there to create the environment to take crap crete to good crete. 'Cause sometimes you might be at home with your wife in the middle at 9 o'clock at night and see the blizzard. You can save your concrete using this method. That being said, there's a flip side to it that if you go a little bit out of control, it could get dangerous, right?
Right? Too much of anything is not a good thing.
Well said, sir. So the system, just bringing up again, or the environment. We had a driveway, 20 foot by 30 foot, 517 pounds total cementitious, 0.45-ish on the water cementitious ratio, 3 to 4 inch slump because there was a little bit of a grade. There was 1% non-chloride accelerator because it is winter. And they used a mid-range water reducer, and of course there was an air entrainment, and we had 5% air on the job site. So somewhere around 7 days would be 3,500 psi-ish. 28 days, 4,500, maybe 5,000 if it was a good cement, like a really out-of-the-park cement. So we're at home. I'm with Whitney. I see it. There's a blizzard out, negative 15. I say, holy cannoli. That was something from my childhood. I just remembered it like a week ago. Holy cannoli. What do? I run out to the shed. I get 15 or 10 blankets, concrete blankets. Get my hose, my generator, my tank, and my water pump, and my regulators. I head to the job site. We set up this system where we have water going back and forth that's at least maintaining within that blanket, within that cocoon, 68 degrees Fahrenheit. We do that, and the next morning, if it was negative 15 at night, what is it going to be in the morning? 4?
Yeah.
Okay? The concrete is 68 degrees or maybe a little bit warmer, I rip off the blankets. What happens?
Don't know. Tell me.
68 degrees concrete temperature, 4 degrees concrete ambient temperature. When you pull that blanket off, you'll have a rapid evaporation loss, you'll have rapid volume change, and you end up cracking the slab. It's called thermal shock.
Right.
We're going to get into that in the different equations that people are diving into, as published by Kevin Folliard, link down below. What do they need to do to steer away from that thermal shock? And this was something that was done in the Hoover Dam.
Well, in the Hoover Dam, they wanted to control the extreme heat. We know that we get a lot of heat when concrete cures. It takes in heat initially, but then it's exothermic as a chemical cure. It can get very hot, 150, 190 degrees Fahrenheit. Towards 200, we don't want to get to the boiling point, that's for sure.
Now this type of slab, it's not going to do that.
No. But on with the story, I mean, they used at the time, copper pipes running through the concrete to cool it internally.
Right.
To help carry away that excess heat.
Regulate the temperature, if you will.
Right.
And why did they do that?
Same reason. You don't want the temperature to increase the volume, swell it while it's in a plastic state, and then not be able to shrink when it's in the hardened state. You get temperature or thermal cracks.
Effectively, you would get dam cracks. I thought about it like 10 seconds ago. I was like, I can't wait.
I should have seen that coming.
Yeah. Sorry. Okay, so we're trying to do the same thing. And the word, I said it, regulate.
Right.
Not heat it, not cool it, but regulate. Even though you are putting, because in those copper pipes they put water plus ethylene glycol and they cooled it? Is that true?
Yeah, I think they had a sequence where in some cases they used iced water, some cases they used water just right out of the river. They had some various sequences for it.
And this was the Colorado
River,
yeah.
Right.
We are trying to do the same thing. With this system, I think we might have called it hydronic heating. Patchouli, what do we call it? I'm not looking at you.
Hydronic heating.
That's not the right way of saying it. It's hydronic regulating.
Right.
What you can do to bypass or to mitigate that thermal shock is reduce that temperature swing below 30 degrees. I think 30 degrees is that 30 or 35 degrees.
Yeah.
Right? And the best way of doing that is regulating the temperature using this hydronic system. Mm-hmm. And you have water. You could put a little ethylene glycol in it, but I would hate to be the person who have to remove that ethylene glycol. You can regulate the temperature of that slab to bring it down to somewhere in that 10, 20 degree range. So if it's 4 degrees out, you can wait one more day till it gets up to 20 and then get your concrete temperature either down to 50 or 40 and then pull your blankets off. Now, you can always take the chance. The closer you get, and the more steel you have, I guess, and maybe if you also had steel fibers, the more resilient you're going to be to cracking. Is that true?
Well, fibers are used commonly to not get big cracks, but to get a system of micro cracks. So you probably still get some cracks. They may not even be visible, but
right.
You still get some.
Yeah, so, you could be a cowboy and see if the closer you get, the less crack tendency there's going to be.
Right.
And we're going to see that in that link below, so please check it out. But yeah, what I love about the hydronic regulating system is that if you do have the patience, and it's going to cost your end user money. And that's something that if you're going to sell to people, that's not a bad idea. Hey, if you want me to pour in the winter, here's an add-on, here's a change order, that if it gets below this temperature, I've got to do this.
Contractors usually have a cold weather clause.
Do they?
Yeah.
Uncle Richard doesn't.
Yeah, most contractors do that. If you're in the winter, they're going to Probably going to change the mix a little bit, make it a little different. They're going to use the blankets. It's just more labor involved. You know, a lot of contractors, I would say most contractors have a cold weather clause.
Cold weather clause. We have a video that we'll post below that we did on a photo analysis. Whitney and I did it. It was a job right by Brooks' house. It was a continuous spread footing with a couple of square columns, or
Right.
paths for square columns. And it was that day that when I parked my car in Brooks' driveway, or in their driveway, pulled the e-brake, the car went like this.
Yeah, slid right down.
Slid right down.
Yeah.
I mean, there was ice everywhere. No blankets. You can still see that the concrete was dark, gray. You see it in the picture. I mean, it was green concrete and everything was frozen. And they weren't but the minimum thickness. I mean, this is a residential
Right.
foundation. It doesn't need to be, what, like 10 inches thick? 12 inches thick?
I'd have to look on foundations. There's probably something like that.
Plus or minus 6.
Right.
Just say. But that being said, listen. I am not the stress strain guy. So when I get those things wrong, it's not intentionally. It's because I haven't talked to David first, which I guess is intentional. But the thing I do know is cement and concrete chemistry. And when you're concrete, they did not use silica fume. They did not color the concrete black. Like, it was brand spanking new, and they ended up tearing it out. Because
Right.
there was a layer of ice over it. And the forms will still up, and there was a layer of ice over everything. It was awesome. So that being said, that contractor could have come back or looked on his phone. Listen, there are a bunch of these weather apps that have notifications on them. That if it gets below, if it starts snowing, it'll notify you. If you're a contractor, one of those things, that's an add-on. And if you have guys who can jump in a truck, or you can jump into a truck, you will look like the hero, the savior. I mean, that job site but next to it was torn out.
Sure.
Which it might be just a foundation for a residential community, a residential home, but it's still a foundation.
Well, that's right. I mean, there's a couple issues, isn't there? I mean, there's the issue that if you let the mixed water, in the surface actually freeze,
Oh my gosh.
then
You're toast.
You're
Surface
toast.
is toast.
yeah, so that's going to be some depth. Pick a number, an inch, inch and a half, 2 inches. That's just not going to cure.
Right.
The ice forming is going to be a volume increase, tension. It's going to crack up. And your best case, in that case, you'll wind up with this gravelly, and it's not pretty. It's not.
No, it's not.
Not like a gravel finish. So that's one case. Or,
And we're talking -15, like real cold snaps here.
Yeah, water freezes at 32. I mean,
But with blankets and with the heat of hydration, 32, theoretically you could, if it's big enough,
right.
could get away with it.
Yeah, agreed. And that's usually the cure for that is the blanket. Then there's the other issue that we're talking about where we get cold throughout the mass or throughout the thickness. And that's a different problem.
With the foundation, if they had this hydronic regulating system, they could have bypassed that problem.
Right.
There comes a certain point that you get too cold of a temperature that you get below the activation energy that the concrete needs. That's the whole maturity
Exactly.
thing. You get below that activation or that datum temperature
Right.
where the concrete's not going to hydrate.
Right.
It just doesn't have enough energy to. You've gotten it so cold. I mean, it's an unfortunate reality, and something simple like, and I hate to say it's simple, but when you see it, it's a Home Depot trip plus a little bit of stuff. Home Depot doesn't have everything. Almost does for this, but it's really getting recognized as the expert on the block if you could do something like this. And I'm pretty excited to get the materials in to make this happen, because we did order some fancier concrete blankets.
Oh.
Thought I had, yes.
Oh.
Yes. Whitney gave me a budget. Concrete blankets aren't expensive.
Yeah.
$50 each, $100 each. They do have concrete blankets now that have heaters in them.
Nice.
They're expensive.
I'll
Like
bet.
a 5x20 is around $2,500.
Holy smokes.
But you buy that once and you put it in as an add-on can pay for that.
Right.
So, anyway, we hope you learned something new. Have a great day. Thanks for your questions. Go Concrete.
Pete Asheville,
That's life. That's life. That's what all the people say.